This is a video solution to tutorial 3a graphing techniques question 4. It is given that f of x is equal to this. F of x means that it's some sort of function. We don't need to worry about what that means, we just need to worry about that this is y equals to f of x for our graphing techniques. We'll go into functions and what they mean for graphs a bit later in chapter 4. But for the moment, we're given that f of x is equal to ax plus b over cx plus d. And we're told AD minus BC does not equal to 0. Therefore, show by differentiation that the graph y equals to f of x has no turning points. So, show by differentiation, that's a bit of a hint. So let's differentiate. So what's f prime of x? So if we differentiate this, we need to use the quotient rule. So to use the quotient rule, first thing I do is I'm going to differentiate the top line. That gives me a. Then multiply by the bottom line, cx plus d, minus the derivative of the bottom line, which is c, times the top line, ax plus b, all over the bottom line squared. So this is how I differentiate this with the quotient rule. Now, I have to show that it has no turning points. So what if this equals to 0, this is when it has turning points, alright? So I assume it equals to 0. Actually, no, I'm not going to do it that way, sorry. What am I going to do? Well, this is ACX plus AD minus ACX minus BC over CX plus D squared. So this cancels. This is AD minus BC over CX plus D squared. So what can you tell me about this number? Well, this bottom line is always non-negative, so it can't ever make the whole thing 0. The denominator can't give us a 0 because, you know, if it gave us a 0, we'd get an asymptote, and if it gave us an infinity, well, it can't give us an infinity by definition. So anyway, the whole thing is, you can only get a 0 here if AD minus BC is equal to 0. But AD minus BC is not equal to 0, therefore the whole thing is not equal to 0, because AD minus BC does not equal to 0. Okay? So, what then can be said about the graph of y equals to f of x when AD minus BC equals to 0? Well, if AD minus BC equals to 0, then f prime of x, which is equal to AD minus BC over cx plus d whole thing squared, would be 0 over cx plus d whole thing squared, which would be 0. Therefore, y equals to f of x, well, or rather, therefore, f of x, if its derivative is 0, f of x is just some constant k. And therefore, y equals to f of x would be a horizontal line. What about the last part? Part 3. Deduce from part 1 that this graph has a positive gradient at all points on the graph. So again, we have to positive gradient at all points. How do we link the gradient to part 1? Well, the derivative is the gradient of the graph at that point. So let's look at if my f of x is 3x minus 7 over 2x plus 1, that means that my f prime of x is going to be what? Well, it's going to be AD minus BC. 3 times 1 minus negative 7 times 2 over the denominator squared, 2x plus 1 squared. So this is equal to 3 plus 14, so 17 over 2x plus 1 squared. And if you look at this, Well, what do you see? Well, 2x plus 1 squared is always bigger than or equal to 0. 17 is bigger than 0, so this whole thing is bigger than 0, so long as x doesn't equal to negative a half. If it equals to negative half, you get positive infinity, which is not a number. So we couldn't say it's bigger than 0, even though, logically speaking, you might want to. So this shows that it, therefore, y equals to 3x minus 7 over 2x plus 1 has a positive gradient at all parts of the graph. Points, of the graph. Just one thing you may ask, isn't x equals to negative half a point of the graph? No, it's an asymptote, so there is no point of the graph there. So my answer is still valid. Well done if you spotted that.